This is HI, okay. Nabil Ahmed, I can't hear you if you are trying to speak. I can see your mic on. Samira, I've just received yours. Samira, can you read what is the first one?
One propoxy propane.
Got it. Okay. So try to write the answers and also write the complete answers. Now you have just written the OH part. I think there will be a haloalkane also, if you remember. You're free to use your notebooks. Okay, all of you. All of you are free to use your notebook. Guys, please start sending the answers, whatever you have done till now. Okay, Matthew, for the first one, yeah, first one is fine. Second one is also, I think, fine. Yeah. Third one, yeah, correct. No. Your answer is not right for the second one. Try to react it, no? Try to do the reaction and then think about it. Phenyl, methyl, ether. So Samira, for the first one, yeah, first one is fine. Second one, fine. Third one, I think you have to think about the third one. Samira, look into your notes. We have done this question actually, as far as I can remember. What is the difference? Like there is a difference, right, in the seconds and the B and C. Think about it. Okay. No one else has sent the answer. If we look at the propoxy propane example, in propoxy propane, you will have 1, 2, 3 oxygen, 1, 2, 3 plus HI. Now, in the reaction with HI, we will get either an alcohol or a we will get one alcohol and one haloalkane. So here there is no difference. That is why we can make the haloalkane from this 3 carbon atoms, and we can make the alcohol from the remaining 3 carbon atoms, OH. In the next one, we have methoxy benzene. So if we look at the methoxy benzene, we have O. That means we have O here, and then we have CS3. Now, either this bond can break or this bond can break, but all of you must know that this bond, which is CO bond of benzene, it is, what is it? It is partial double bond character. It has partial double bond character, and that is why when it reacts with HI, it gives it that CO bond does not break. The CO bond of benzene will not break because it is having partial double bond character, and that's why it will be phenol plus CS3I. But if I look at the next structure, that is benzyl ethyl keter. So benz is the structure. A benzene ring with a carbon atom is a benzyl. CH2, then O, and then ethyl. So we have C2H5 plus HI. Okay, fine. Whatever I send, I will see all of your answers. Don't worry. Okay. Now, here what is happening? Here you can see that we can either break this bond or we can break this bond here, right? So if I break the red bond, then you can see that easily this carbon atom is going to get a positive charge, and this carbon atom which is getting positive charge, this positive charge will be delocalized, and when such is delocalized due to resonance, it will be more stable. That is why we are going to break which bond? We are going to break this red bond here, and we are going to form CH2I plus C2H5OH. Now this question, second question, is related to this B part here. They're saying phenyl methyl ether reacts with HI. So we have phenyl methyl ether. It reacts with HI. Now there are two possible products. You can either make Iodo benzene. Can make Iodo benzene and methanol. Or we can make what? We can make a phenol and iodo methane. Now, if I am going to get this A product, these A part, then I have to break this bond, and this bond cannot be broken due to partial double bond character. Because of resonance. Okay, and you can show that. It can go like this. Okay, so it will have partial double bond character. I mean, just to get the bonds correct. Okay, so you can write some parts here. Okay, fine. Astha, you have sent me first. I'm looking at your answer. First one fine, second one fine, third one you did not attempt. Third one is fine. Yes, third one is fine. And then Nabil Ahmed, he has sent me the answer. Okay, for the first one it's fine, second one fine, third one is not fine. I hope you can see why it is not fine. Nabil Ahmed, the third one. Khalid. No, it's not CCC, Khalid. What you have written is you have to keep it in your brain. You have to not tell the CVSA about it. That's not the reason. That's how we identify and how we write the product fastly. You have to give the reason. The reason is that this CO bond is going to break. This CO bond is going to break, and not this CO bond. This means CO bond has partial double bond character. That is why it does not break. And we get this product. Right? That's what they are saying. Reacts with HI to give phenol and methyl iodide, and not this product is not formed. Why it is not formed? Because if I am going to form iodobenzene, I have to break this bond, which is very difficult to break. You got it, Khalid? Yes or no, Tini? Yes, Khalid?
Yes, sir. Yes, sir. Got it.
And then we have Khalid. Because no. So where did you get this answer? Both of you have written the same answer. कहाँ से छापा आप लोगों ने? Khalid, tell me. Where did you write this answer from? Yes, Khalid. Because I negative prefers to combine and react with a smaller alkyl group to minimize steric hindrance. Khalid, can you please turn your mic on?
Sir, I wrote this like before in assignment. It was there, like some assignment. It was there in school, so I got it from there. I remember
about
this
Sabine?
question.
Khalid, where did you write this from?
So from my school notebook.
ये तो गलत दिखाया आपने.
Second one, right?
Second one, second question, yeah.
Yes, sir.
I negative prefers to combine with. I mean, prefer की बात कुछ और ही होती है, but here this bond is not going to break. That is why we are not forming that bond. Okay. So आपके स्कूल में teachers लिखवाते हैं आपको answers?
No, it was a bigger answer, but I didn't try the full.
It was a bigger answer. What can you read the answer?
Phenyl methyl ether does not reacts with HI to give phenol and methyl iodide because the lone pair of oxygen are involved in resonance with the benzene ring and imparts a double bond character and increases the CO bond with the benzene ring. And
let me complete. And
because iodine ion prefers to combine with the smaller group to minimize the steric hindrance.
okay. The first part is fine. The first part is fine. It is due to the partial double bond character. Okay. So this can only form. See, if it was not for partial double bond character, then what would have happened? Some of this product would also have formed, but this bond does not even break. Okay. So this bond, the CO bond of benzene ring, it does not even break. So that is the main reason why we are not writing that product. Okay. Good. Right now, chemical tests. Right, number one. Lucas reagent. What is Lucas reagent used? Lucas reagent is used to distinguish between
primary, secondary, and tertiary alcohols.
distinguish between. Can you repeat that?
Primary, secondary, and tertiary alcohols.
1 degree, 2 degree, and 3 degree alcohols. Okay, so for example, if they ask you, let me give you some questions by the way. Okay, so give one chemical test to distinguish between the following pairs of compounds. You will be asked question like this. In that, you have to first of all make the product, make these two compounds. 1 propanol, 2 propanol. What is the difference between them? It is 1 degree. This is 2 degree. So this can be distinguished by Lucas reagent. Okay, so right. Anhydride and Cl2, no reaction at room temperature. Okay. This is going to give me turbidity. That means to give this product which is turbid in its properties. Okay, after 5 to 10 minutes. Done all of yes or no, please tell me.
Yes, sir.
No, sir, 1 minute.
Okay, right.
No, can you go a little more up?
Or up? Okay.
Then, sir.
Done, sir.
Yes, sir, done.
Next is Victor Mayer test. In Victor Mayer test also we distinguish, and it is basically used for the confirmatory test. It is used as a confirmatory test for 1 degree, 2 degree, or 3 degree alcohols. So you will write phosphorus plus I2 okay. So if you remember phosphorus plus I2, and we are going to react this with alcohols. If you are going to react this with alcohols, then what do you think? What will be the product? Tell me. Phosphorus plus I2. What will be the product? Phosphorus plus I2. Think. You have done this in haloalkane, halorine also. You have done this in alcohol chapter also. In both the chapters, you have done this. Okay, what happened? I thought you will answer me something. So if I react this with phosphorus, the presence of I2, it is going to convert itself into what? Itself into iodoalkane, right? If I react RCH2OH. That means we are using 1 degree alcohol. If I use 1 degree alcohol, I will get 1 degree haloalkane, RCH2 iodine. And if I have a 2 degree alcohol, that means 2 alkyl groups, CH connected to OH, will have 2 degree alcohols, and it will convert itself to 2 degree haloalkane, CHI, and specifically iodoalkane. And at last, we have R3 carbon and OH, 3 degree. It will get converted into R3 carbon and iodine. Now, after this, we will react all of these iodoalkenes with AgNO2. This is also one reaction that we have already seen, AgNO2. Now, when I react this with the AgNO2, then it is going to form nitroalkane, if you remember from the chapter haloalkane, halorine. Okay, so we'll have R CH2NO2, R2CH, NO2, R3CNO2. After this, what do? We react this with ONO. ONO is nitrous acid. HONO, ONO. Okay. After that, once we react this, we are going to get some products. So if I react the 1 degree alcohol, we are going to get this product, which is R, that is bonded to carbon atom. And now this carbon atom, it has the NO2 group as it is, and it will have double bond NO bonded to H. Then this 2 degree, it is going to give me the same thing, but we are going to have R2 with the carbon atom, and we are going to have NO2 here and this nitrogen will not have NOH, rather it will have only NO. And here it will give me no action. Now, if you see all of these products here, they are going to behave differently in the presence of base. I can't make it like this. Wait a second. Yeah. So if I add a base here, if I add some alkaline thing, then it is going to get converted into blood red color. Blood red in alkali. Now this 2-degree one, it will convert itself into blue color. In alkali. If I don't have anything, then it is not going to have any color. It will be rather colorless. Now this reaction here, all of these things, these are not present in your NCERT, but this is something that you should know, because in Viva, when you have the board's Viva, in that case, they can ask you, how will you distinguish between 1 degree, 2 degree, 3 degree? You are thinking that they're asking a very easy question, that is, you will answer that it is Lucas reagent, sir. Then they will say, okay, fine, I got some sample of organic compound and I reacted it with HCl and ZnCl2. I got the product after 2 minutes. Okay, I got the product after 2 minutes at the room temperature only. Now they will ask you whether it is 2 degree or 3 degree, or they will ask you it is let's suppose that I got the product in 3 minutes. Then what do you think? It is 2 degree or 3 degree? Then we have to do a confirmatory test, and that confirmatory test can be done by Victor Meyer test. And also because this is a long, जो भी थोड़ा सा लंबा होता है, I mean the tests which are a bit longer, those tests we do only to confirm something. So once the teacher asks you whether it is 2 degree or 3 degree, then you will say that we will do a confirmatory test, and he will ask what test is that, you will say it is the Victor Meyer test. So in Victor Meyer test, if I'm getting a colorless solution, that means it is a 3 degree. If I'm getting a blue color, then it is going to be 2 degree. Okay, so it is only used for confirmatory test in your examination in CBSE. If they ask you to distinguish between any 1 degree, 2 degree, or 3 degree alcohols, you are going to use Lucas reagent. Please don't write Victor Meyer test, because it is kind of long and it is going to use a variety of reagents which you will not be able to remember. Okay, but please revise this before going to the Viva for lab. Write this down. Let me know when you're done. Then we will.
This is only for Viva or?
No, self Viva, only Viva, not for your board examination for sure. Okay, because it has many reagents ना, आपको सारा याद करना भी मुश्किल रहेगा, कुछ गलती हो जाएगी तो मार्क्स कट जाएंगे. इसमें Lucas reagent आप याद करते रहिए, there is no problem there.
Sir, Lucas reagent, tertiary alcohol, how it will react, sir?
It does not show reactions actually, no. See, in tertiary alcohol, you can see that this RCC bond is there, right? Here also you can see what bond is getting broken. Here the CH bond is getting broken, right? Both of the CH bonds. Here also CH bond is going to break. But here in the absence of CH bond, it is not going to react. Okay, so no reaction happens here.
And Lucas reagent also, sir?
No, not to Lucas reagent. Lucas reagent, it will give the product immediately for 3 degree.
Yes, sir.
Right, for the third one, those who have written this, Iodo form test. All of you done? Yes or no, please tell me. If you're not done, just let me know. Okay, all right. All alcohols containing CH3, CH, OH group. If it contains this group, if there is any alcohol which is containing this type of group, linked to carbon or hydrogen, can be distinguished by Iodo form test. If you remember, we have seen this reaction actually. So for say, let's see a simple example. Here I'm taking CH3, CH2OH. Okay, so what you have to see, this hydroxy group should be in the second last carbon atom. Okay, so it should have one CH3 group. Okay, so you first of all identify the carbon atom that is containing the OH, and there should be at least one CH3 group adjacent to it. If that is present, then it is going to give you Iodo form test. So I will react this with I2 in the presence of NaOH. And this is going to give me Iodo form, CHI3. This is yellow PPT. Plus HCOONA, sodium iodide, and water. Okay.
Well, this one is not only for Viva, right?
No, this one is not for Viva. This one is for your exam also. Iodo form test we'll be looking at the next chapter also. Okay, so I hope you guys are done. So for example, if I have methanol for that matter, the presence of NaOH, this is going to give me no reaction, right? Because this carbon atom which is connected to OH, it is not connected to any CH3 group. Like the question. Which of the following rather, let me ask another question. How will you distinguish between A,
Sir, could you show the Iodo form test part again?
this is the test, reaction,
No, so the description part.
okay?
Yes, sir.
Wait a second, not 2-butanol, right? 2-pentanol. And 3-pentanol. When the number, that is 2 and 3, these are written before the parent gene, they represent the numbering of the functional group. Okay. Or sometimes the double bond and triple bond. But right now we don't have double bond and triple bond. That is why these are representing the functional group. Okay. So 2-pentanol means we mean by that pentane 2-ol. 3-pentanol means pentane 3-ol. You write the structures and tell me how will you distinguish between them. You can send the answer. You can just write the name of. No. You have to show me the reaction in WhatsApp. First of all, draw the structure of these two compounds. I have to see that also actually. So you will send the answers on my WhatsApp. Okay, what happened, guys? Who answered till now? But you can't write the structures also. Please write the structures and tell me. I'll wait 2 more minutes. How will you distinguish it? Tell me. Sir, I don't see like anything real here. Like both of them are making the same product. How can you distinguish between them? Khalid, correct, yeah. Nabil, your answer is correct. Guys, what happened? Samaira and all, please. Oh, आप लोग ध्यान नहीं दे रहे क्या बिल्कुल क्लास में?
Sir, reaction with NaOH.
Sorry. Reaction with? What happened? Samaira, Hishma, Astha, send the answers. Nabil Khan. Many people are there who are not sending the answers. Nawal. Send these structures, all of you. Send these structures. I don't need the answer. Send these structures at least. No, Salman. How? Salman, can you please turn the mic on? Ye humko, this is not right actually. You know what? This is not right. Turn your mic on, Salman. You can't. What is this 1 degree, 2 degree? Tell me. 2 pentanol is 1 degree or 2 degree? Salman, tell me, it is 1 degree or 2 degree? Look and tell me clearly, okay? Yes, Samaira, correct. And Nawaz, your structures are fine. Salman, tell me, what is this? 1 degree, 2 degree or 3 degree? Yes, Astha, correct. If you see both of these structures are 2 degree, yes or no? Can I get an answer? Bhai, आप लोग कुछ बात ही नहीं कर रहे हैं आज.
Yes, sir.
Yes, sir, both are 2 degree.
So how will you distinguish them with Lucas reagent? Lucas reagent will only be used if you have 1 degree or 2 degree. You have 2 degree or 3 degree. If you have 1 degree or 3 degree. Between 2 degrees, there will be no, I mean, what will be the difference, guys? If I react both of them with Lucas reagent, I will be getting turbidity under 5 minutes, yes or no?
Yes,
Both
sir.
of them will
Yes,
give me.
sir.
So how can we distinguish with Lucas reagent? Right? Now here what we have to do. Here we have to see that this carbon atom, which is containing the hydroxy group, it has a CH3 group here, right? So this is going to give me iodoform test. And this is not going to give me iodoform test. Write this fast. See, and the product for iodoform test is always going to be this. You will write this part, CH3I, CHI3, okay? So no matter what is your alcohol, that is the only product you will write, and you will not worry about the other products. So if you have this OH, 2-pentanol plus I2 in the presence of NaOH, we are going to get CHI3, yellow PPT. That's it. After this, you will write the last part. Okay, Salman, no problem.
Answer 1 minute, sir.
No, खुद से लिखिए. This is something that we have already done. Na? Leave some space. For this, phenol versus alcohol. Okay. So in this A part, we'll write litmus test. Now, if you have litmus, then phenol will convert blue litmus to red. Okay, so we'll please write phenol turns blue litmus to red. Third one, alcohol has no effect on litmus. On litmus solution or litmus paper. Okay. Then B part is bromine water. So phenol, it reacts with bromine water to give white PPT. Phenol reacts with Br2 aqueous to give white PPT.
Sir, alcohol will have no effect on blue litmus or all.
No, no, it is very much similar to water. It has like, it is slightly A only.
Yes, sir.
Okay. So here we are going to get tri-substituted phenol, if you remember. Because we are using here water, water will turn the phenol to phenoxide ion, which will make it very much activating. And this tribromophenol, it is white PPT. Alcohol does not react with bromine water. Write this down, then write another question. Of the two hydroxy compounds, ROH and R-OH, they are saying that ROH is basic and R-OH is acidic. They're asking how is R different from R-. Now we know only two things, two different classes which contain the OH, right? Which contains OH. What we know, alcohol and we know phenol. Both of them has the hydroxy group, right? Both of them has the hydroxy group. Now if I see phenol, it is more acidic than alcohol. That is why this R-OH is going to be phenol. And the alcohol here, it will be acting as base, which is alcohol. Okay, so we'll say that R is alkyl group and R- is phenyl group. Since alcohol is a weaker acid, or we can say that alcohol acts as a base more often because it has even less acidic character than water. So if something is less acidic than water, then in water it will act as a base. And that is why we can say that R- is phenyl group and R is alkyl group.
Sir, we can't say whether it is on the basis of like whether R dash is secondary or primary. Because primary alcohols are most acidic, right, sir? So we
No,
can't
but
say
all the
ROH
alcohols,
is
all the alcohols, they are weaker acid than water, right? Yes or no? If I compare alcohol and water, which is more acidic?
water.
Water is more acidic. That means alcohol is how it will act generally as a base or an acid.
Base, sir.
You got your answer?
Yeah.
You got your answer, Nabil?
Yes, sir.
So write a question. How will you distinguish between methanol and phenol? You have to give a chemical test. You can write using bromine water. And then show the reaction, okay? So reaction of phenol. Just please don't write using Br2 aqueous. इतना मत लिखिएगा please, okay? Then you write these two statements. Phenol plus the blue litmus, sorry, phenol will react with Br2, but ethanol. यहाँ पे alcohol को change करके क्या लिखना पड़ेगा आपको? Ethanol does not react with Br2 aqueous. But instead of ethanol, they can give you methanol. So you just change the answer to methanol does not show any reaction with Br2 aqueous, bromine water. Done, guys. Is it sir me?
Yes, sir.
1 minute,
sir.
Okay. Done, everyone? Done? Yes or no? What happened? क्या कर रहे हैं आप लोग इतना देर?
Yes, sir. Finish.
Carbonyl compounds. It's Tuesday, no? Write the topic. Chapter's name: aldehyde, ketone, and carboxylic acid.
Sir, you will get 246 tribromophenol, right?
Correct. You have made that product only, ना? लिखा नहीं क्या आपने? You have made this product.
Yes, sir.
Right here, aldehyde. Ketone and carboxylic acid. Now, in this chapter, we are going to see a few molecules. Those molecules will be aldehyde. Structure of aldehyde looks something like this: C double bond O with one hydrogen. It is sometimes written as CHO. Not sometimes, it is most usually written as CHO. This is an aldehyde. And if it is acting as a functional group, we write the suffix Al in the IUPAC nomenclature. And here we will have some R group attached. Okay, some R group will be there. So this is aldehyde fragment. If you see this fragment here. Similarly, we have ketone. So ketone will be C double bond O. There will be some R group here, some R group there. So whatever I have not shown, that is an R group. It is connected to carbon atoms. Okay, if I have not shown the atom, it is carbon atom, and it will be sometimes shown something like this. Same thing, no difference. Ketone, and if it is acting as a functional group, then we write it as ONE. And then we have carboxylic acid, which is C double bond O and OH. So this is carboxylic acid, and okay, sorry. It is often written as COOH. And if it is acting as a parent, if it is acting as a functional group, then we write oic acid and the IUPAC name. Then we will also see in this chapter esters, C double bond O and O R. Okay. Now ester, this is the parent carbon chain. Okay. This carbon is going to be the parent carbon chain. And this R group, it is a substituent. Please remember that this R group, this is the ester group. This R group is not a part of ester. Okay. This R group is a part of substituent. If we have ester, sorry, so this will be written as COOR. Okay. In this part, only this much is your ester. Okay. And whatever bond and whatever carbon atoms are after this carbon atom. Okay, that is a part of parent chain, and the R is going to be your substituent. Then we have this ester, and we write it as O8. Okay, so these are the four major things that you are going to see. And one more thing that you are going to see in this chapter is acid anhydride, but not very often. So this has a structure like this: C double bond O, oxygen, C double bond O, and then some other carbon atom. So if it is acetic anhydride, then it will be made by acetic acid, that is CS3, C double bond O. And then we, instead of writing OH, we'll write O, and then C double bond O, the same thing, CS3. So this is acetic anhydride. Okay, acetic anhydride. This is known as acid anhydride. In general, whatever acid is there from which it is made, anhydride. Okay, so it is not a functional group. Write these things down. Then first of all, we will look at the nomenclature of aldehyde and ketones and carboxylic acid mainly. First of all, common names, and then we will move to the IUPAC nomenclature. Right here, nomenclature.
So 1 minute, sir.
Mhm. Common names. Done? Yes or no, please tell me. Saf,
No, sir.
let me know when you're done.
Yes, sir. No.
In common names, you will write first of all. See, the aldehyde and the ketones, both of them, they derive their common names from the carboxylic acid. Okay, from the carboxylic acid. Now, please understand this first. I will give you time to write. Okay, I will give you time to write. Please understand this first. We have acetic acid. You will remember this few names here. Okay, acetic acid, that is CH3, C double bond O, OH. Now, if you look at the fragments of carbon atoms, we have two carbon atoms here, right? We have two carbon atoms, but don't think of it as two carbon atoms. You see this fragment, you write the same fragment, and you want to make an aldehyde out of this. So what you are going to do, you are going to add a hydrogen. So this is going to be acetic acid. So this is going to be acid aldehyde. And please see, we are going to do the same thing. We are going to take this fragment, CH3, C double bond O, and I want to make a ketone. So in order to make a ketone, I have to add a CH3 group, right? So you just need to look at the C. This is the smallest ketone that you can make, and this is going to be your acetone. This is acetone. Okay, some people get confused that acetic acid, it has two carbon atoms. Acetaldehyde, it has two carbon atoms. Why does acetone has three carbon atoms? So you don't have to remember it in a way of carbon atoms. What you have to do, you have to remember it as a fragment. So this is the fragment here. So this fragment is acid. Okay, this fragment is acid, ACET. Okay, if it is having OH, then it is acetic acid. If it is having only hydrogen, it is acid aldehyde. If it is having CH3, then it becomes a ketone, so it is acid. Okay, then right next, we have the next one, which is known as formic acid, which is H, C double bond O, and OH. If I want to make the same with aldehyde, I have to do H, C double bond O, and then a hydrogen here. I cannot make a ketone because there is only one carbon atom here. We cannot make we at least need three carbon atoms. Okay, so there is no corresponding ketone for this. This is known as formic acid. This is formaldehyde. Okay, this is formaldehyde. Then these are the most commonly used, like the acetic acid and its corresponding aldehyde and ketone, formic acid and its corresponding aldehyde. Then we have one which is known as propionic acid, which is CH3, CH2, COOH. Now the corresponding aldehyde is going to be CH3, CH2, CHO. Okay, we don't have to remember the corresponding ketone. So the ketone, the only ketone that you have to remember as this part, it is acetone. And when I say you have to remember, you have to remember. This is propionic acid. This is propion aldehyde. Then we have one more. You can start writing now. I hope you have got the gist of it. So you can start writing. You will have CH3, CH2, CH2, and then COOH. Now we have four carbon atoms. So it is butyric acid, and the corresponding aldehyde will be butyraldehyde, CH3, CH2, CH2, three carbon atoms, and CHO. This is butyric acid. And this is butyraldehyde. Please write this down. Let me know when you're done. Then we will move on and we will see that how we are going to write the substituent in common names. Okay. The common names have not been asked in CBSE till now, but there is high chances that they can be asked. Okay, so that's why I'm teaching this. And also, if not directly in IUPAC nomenclature, they can be asked in terms of conversions and all. if you are written like how will you convert propane aldehyde to propionic acid, then you must know what is propane aldehyde and propionic acid. Similarly, how will you convert formaldehyde to formic acid and so on. Okay, so for conversions also it is important to know these common names. Sometimes these are also used. Done all of you, so please tell me.
1 minute, sir.
One minute, sir.
Please try not to look at the screen and write on your own, because once you have listened to it, it must be there somewhere in your brain, and just try to write it from your memory. Okay, you have seen the screen, you have seen all of the structure, you have seen the name also. Like in the names, what you can do is you can just write the acetic acid and those part, and not write the acetaldehyde, formaldehyde, propionaldehyde, and butyraldehyde. Okay, so try to gain as much, like try to retain as much as you can in the class itself, so that you don't have to revise a lot at home. Then guys, listen up, please tell me.
No, sir.
Saf, done?
1 minute, sir.
If you are not done, those people who are not done, they should be prompt and they should be answering no, sir. Okay, जिन लोगों का हो गया हो तो yes sir बोल ही देंगे, जिनको यहाँ पे रुकना है वो बोलेंगे no sir, not done. Okay.
Yes, sir, done.
Sir, can
Now
you just
we'll write it.
show it, sir?
Sorry,
Can you show it one more time, sir? Just a
one
minute,
more
I'll just
time.
sketch.
ठीक है, जल्दी बताइए होगा.
Yes, sir. Got the picture, sir.
याद रखने की कोशिश कीजिए फोटो लेके क्या होगा.
Sir, in the last 4 cases, we won't have.
No, you don't have to remember the corresponding ketone. Ketone, you are asking about ketone?
Yes, sir.
No, you don't have to remember the corresponding ketone. The only ketone that you have to remember from here, you have some other common name for ketone that we use generally, that we are going to look, but right now you don't have to look at. Okay. Mainly, see the carboxylic acid and the aldehyde, they're also similar because they can only be found in the terminal carbon, right? That is why you have the most, like we commonly use the aldehyde and carboxylic acids commonly. Then you will write, please write this with me. Please write this with me. Use of alpha, beta, sorry, alpha, comma, beta, comma, gamma for positions of substituent. For position of substituent. Okay. So for example, I'm writing here 1, 2, 3, 4 carbon atoms, and here we have COOH. Okay. So this first carbon atom is going to be my alpha. This is beta carbon, and this is gamma carbon. Okay. Then if I have a, let's say, aldehyde, CHO, this first carbon is alpha, beta, and gamma. Okay. So let us suppose we have been asked to write the structure of this molecule. In common name. So see this part here, if you identify this part, this is having 4 carbon atoms. So this is going to be your butyraldehyde. Okay. And then we have this part, which is my substituent. It is what? It is a methoxy.
So beta methoxy butyraldehyde.
Yeah, correct.
Yes,
So it will be beta methoxy butyraldehyde. Okay. Beta methoxy butyraldehyde. Write the name for this one.
alpha methyl
Write in chat, write in chat, write in chat.
sir, alpha methyl ethanaldehyde.
No, no, write in chat, please see. What is the common name or not? Whatever I have done here, now please try to do that in your notebook and then write the name. You will not get it on top of your head. You have to like work around. And please send the answer in chat, okay? When you're done, please send the answer in chat. You can use the word instead of alpha, you can use the A word. Instead of beta, you can use the B word. Okay, the capital B.
Sir, I've sent it.
Yes, Nabil, correct. Khalid, yes, correct. Right, guys, very good. What about others? Khalil, correct, very good. Yes, Astha, correct. No, Samaira, not correct. Samaira, please see alpha, beta, gamma, ek bar, then answer again. Samaira, please see alpha, beta, gamma, and then answer again. Hishma, yes, correct. Okay, there are a few people who are not answering till now. Minashi, yes, Minashi, correct. Samaira, did you get your mistake? Yes, Samaira.
Yes, sir.
Okay, so please send the corrected answer.
Sir, I have sent.
You have sent. I have. Okay, fine. You're correct. Matthew, again, try once more. Yes, correct. Position, please try once more, Matthew. All of you have got this name right. So we have 1, 2, 3 carbon atoms. That means it is propionaldehyde. And the CH3 group is attached on which carbon atom? Please tell me, guys. This is methyl. You have got this also right. All of you have got this right. Matthew, just waiting for you. This carbon atom will be what? Alpha, beta, or gamma? Yes,
Alpha.
Matthew, please tell me. Alpha, no? Right. So it will be alpha methyl. Propionaldehyde. Okay. Now let us look at the names, the common names generally that we use for ketones. Okay, so ketones are also named something like this. See, each and every ketone, it will have C double bond O, which will be attached to some alkyl group. Let us say this is CH3, and let us say here we have CH2, CH3. So if you see this molecule, then initially how they started naming it. So this is a ketone. Obviously, it is a ketone. So they said that behind it is a ketone, and it has a methyl group and it has an ethyl group. It has a methyl group and it has an ethyl group. Like 2 groups are there. So they said that okay, fine, we can name this as simply as ethyl, methyl, ketone. Okay, but what will if we have the same groups? Let us say we have CO and we have here CH2, CH3. Here also we have CH2 and CH3. Then I will name it as we have ethyl group here also. We have ethyl group here also. So rather than ethyl ketone, will name it as diethyl ketone. So this diethyl is telling me about the 2 alkyl groups that is on the either side of the ketonic group, which is CO. Similarly, you will have C double bond O, CH3, and CH3. So this can be named as dimethyl ketone. It can also be named as acetone if you remember. All of these are common name for this. Okay, not IUPAC nomenclature. All of these are common name. Now, when you have something like this, that means a benzene ring, it is attached to C double bond O and CH3. Then if you look at this fragment, this is acid, right? If you look at this fragment, this is acid. So it derives its name from there. It is acetophenol. Acetophenol. Okay, so this acetophenol is also used in your IUPAC nomenclature. Similarly, we have one more thing. Benzene ring, we have C double bond O. And then again, we have a benzene ring. So this is known as benzophenol. Right. So we have this part, which is benzo, you can say. So what is benz? Benz is the benzene ring with one carbon atom. So this part till here it is benzo. Then we have a phenyl group. That is why it is benzophenol. Okay, that's why it is benzophenol. Okay, so I think let's stop here, I guess. Hello.
Sir, can you scroll
Right.
little up?
Sorry,
Can you scroll little up?
scroll a little up. Fine. A bit more. Oh, that's fine.
No, no, yes.
That's fine. Okay. I hope all of you guys know that on next class, that is Thursday, you will have a test on the complete chapter of alcohol, phenols, and ethers, including the chemical test that we have done today. In Also in chemical test, we just have to remember two tests. That is the iodoform test. Sorry, three tests we can say: iodoform test, the Lucas reagent test, and the bromine water test. That's the three things that you have to remember. That's it. Done, guys. Yes, no, please tell me.
Yes, sir.
Okay. So something as a bonus, I learned this recently, so I will teach you something that is not related to chemistry, but I think it will be helpful for you guys. Okay. So, like subtracting things, if you have to borrow something, so it is sometimes mentally taxing. Like if you want to subtract without using pen and pencils, then it is difficult to subtract something like this. We have, let us suppose, 57, and we want to subtract from here, let us say 51 or 52, and we have to subtract 37, right? So instead of going from right to left, we will go from left to right. So 5 minus 3, please tell me what it is. 5 minus 3 is
2.
2. And 2 minus 7 is
-3.
-5.
minus 5. And you just need to do 20 minus 5, which is equal to how much?
15.
15 is the answer. You can go even further. 123, let us say, and you have here 86. 12 minus 8 is how much?
4.
4.
4. 3 minus 6 is
-3.
minus 3. So 40 minus 3 is equal to
37.
37.
a bit easier.
Yes, sir.
Yes, sir.
Okay, fine. So thank you guys. Thank you very much. Also ask your class second and third, whatever